Imagine building an interactive Kanban board, a customizable dashboard, or a file manager, and giving your users the power to effortlessly reorder items without bloating your app with heavy dependencies. That's what mastering drag-and-drop list reordering in React using only the useRef hook is all about. In this tutorial, you'll discover how to unlock full control of the drag-and-drop experience, from accessing the real DOM in a React-friendly way to implementing intuitive, high-performance list reordering and ensuring your solution is accessible to everyone. You'll learn the exact mechanics of connecting React State with native browser drag events, how to provide seamless visual feedback as items move, and how to make your components keyboard accessible for true inclusivity. Whether you're aiming to reduce your bundle size, customize every detail of the user interaction, or simply want to deepen your understanding of React's capabilities, this guide will equip you with the skills to deliver interactive features that feel smooth and professional. If you're ready to take full ownership of your app's interactivity and push your front-end skills further, make sure you subscribe. Stay tuned for ongoing in-depth tutorials that empower you to build smarter, faster, and more accessible apps, without the crutch of external libraries. Imagine a bustling post office where parcels are sorted and moved from one shelf to another based on their priority. The workflow is smooth because every worker knows exactly which shelf each parcel is on at any given moment. This analogy mirrors React's approach to rendering and state. In React, rather than allowing direct changes to the shelves, the DOM, there is a virtual registry, the virtual DOM, where all changes are planned and orchestrated for maximum efficiency. However, some operations, like the act of physically moving a parcel from one shelf to another in response to a user dragging it, require direct access to the actual shelf. This is where the useRef hook comes into play. useRef acts as a persistent pointer to a real DOM node, much like a worker's clipboard with exact shelf locations. It enables React developers to bridge the gap between declarative UI updates and imperative DOM actions, especially for drag and drop. When dragging a list item, we use useRef to track which item is being moved and where it will be dropped, ensuring the interface responds instantly to the user's actions. This hook thus forms the backbone of custom, performant drag and drop logic, empowering developers to synchronize the virtual plan with real-world DOM changes without waiting for a full re-render. By understanding this, developers gain the ability to implement highly interactive features in React while maintaining predictable, optimized updates. Envision a chessboard where each piece can be moved according to strict rules, and every move changes the state of the game. In a React application, a drag-and-drop list functions similarly. Each list item is like a chess piece, and moving an item to a new position updates the stateful representation of the list. The core logic of reordering involves calculating which index the dragged item should occupy after the move, and then immutably updating the list to reflect this new order. This is akin to moving a knight from one square to another and updating the board accordingly. React's state must remain immutable, like taking a snapshot of the board before making a move, so that changes are clear and can be undone or replayed if needed. The drag and drop events, onDrag start, onDrag enter, onDrop, onDrag end, act as the game's rules, dictating when a player can pick up, hover over, and place a piece. By handling these events and updating the list state in response, developers ensure the UI always reflects the current state of play. Furthermore, visual feedback, such as highlighting the potential drop target, helps users understand the impact of their actions, just as a chess player visualizes possible moves before committing. Through this analogy, it becomes clear that precise, immutable state management and clear visual cues are essential to intuitive, reliable drag-and-drop list reordering in React. Consider a library where readers can rearrange books on a shelf to suit their preference, but not everyone is able to use their hands to move the books. Accessibility in UI design ensures that everyone, regardless of ability, can interact with and benefit from the interface. In the context of drag-and-drop list reordering, Accessibility means providing keyboard controls and assistive cues in addition to mouse-driven interactions. ARIA, Accessible Rich Internet Applications, attributes serve as labels and instructions for screen readers, much like Braille labels on bookshelves. For example, ARIA Grabbed communicates to assistive technologies whether an item is being dragged. Keyboard support allows users to pick up and drop items using keys like space or enter, and to move items up or down with arrow keys, ensuring the interaction is inclusive. Focus management is crucial. After a reorder, the focus should remain on the moved item, analogous to a librarian ensuring the reader's gaze follows the book as it's relocated. By layering these accessibility features onto custom drag-and-drop implementations, developers create interfaces that empower all users, illustrating that a truly interactive experience is one that leaves no one behind. Picture two contrasting kitchens, one with every conceivable appliance and gadget, the other streamlined with just the essentials, yet both capable of producing gourmet meals. When it comes to implementing drag and drop in React, developers face a similar choice. Libraries like React Beautiful DND provide a rich set of features, built-in accessibility, complex drag scenarios, and polished animations, much like a fully equipped kitchen. However, these libraries also add overhead, increase bundle size, and sometimes restrict customization. A custom, useRef-based approach, on the other hand, is the minimalist kitchen. It requires a deeper understanding of the basics, but offers complete control over every aspect of the interaction. Developers can tailor the experience to their specific needs, avoid unnecessary dependencies, and keep the code base lightweight and maintainable. This method also fosters learning as it exposes the inner workings of browser drag events, state management, and accessibility. By weighing the pros and cons, developers can choose the approach that best fits their project's requirements, knowing that a useRef-driven solution can match the power of any external library when crafted with care and expertise. Imagine orchestrating a performance where each musician must play their part at precisely the right moment without unnecessary repetition. In React, this precision is achieved by optimizing renders and managing mutable state efficiently. When building drag-and-drop features, using useRef to store drag indices and interim state avoids unnecessary re-renders, much like a conductor signaling only the relevant musicians rather than the entire orchestra. Memoization techniques, such as React.memo, ensure that only the affected list items update during a drag, preserving performance even as the dataset grows. For large lists, virtualization, rendering only the visible items, is akin to spotlighting just the current performers on stage, keeping the process snappy and resource efficient. Animated transitions, whether via CSS or JavaScript, add polish, seamlessly guiding the user's attention from one item to the next, like a well-choreographed scene change. By leveraging these advanced patterns, developers can deliver drag-and-drop UIs that feel immediate and fluid, regardless of scale or complexity, ensuring that every user interaction is both efficient and elegant. This is the main React component responsible for rendering and managing the drag-and-drop list reordering logic. It leverages useRef to track the dragging state and updates the list order on the fly. The component is fully accessible, supports keyboard navigation, and applies visual feedback to the dragged item. This is the main application entry point. It imports the drag-and-drop list component, provides the initial item's data, and defines a handler to receive reordering updates. This file wires up the drag-and-drop list into the user interface. This is the data module containing the initial list of items to display in the drag-and-drop list. Each item includes a unique ID and a label. This CSS file provides the necessary styling for the drag-and-drop list. It defines the layout, appearance of each draggable item, and visual feedback for the currently dragged element. This is a test file that demonstrates how to automate testing of the drag-and-drop functionality. It uses our testing library React to render the list, simulate drag events, and verify the reordering logic. This configuration file lists the project dependencies and scripts. It includes React, React.DOM, Vite for development, ESLint for linting, and Jest with testing library for testing. The demonstration begins by scrolling through the application's header and introductory content, showcasing a modern interface that introduces the drag-and-drop functionality. The view smoothly transitions to the section titled 1. Kanban Board, Multi-Column Reordering. Here, a classic Kanban board is presented with multiple columns such as To Do, In Progress, and Done. The interaction starts by selecting the card labeled Design Homepage from the To Do column. This card is dragged and dropped into the In Progress column, visually moving the card between columns. The Kanban board instantly updates, reflecting the card's new location. Next, within the In Progress column, the card Implement Login is dragged below the card Setup Database. The order of cards in the column updates immediately, confirming the successful reordering. To illustrate keyboard accessibility, the card Setup Database is focused. By pressing the spacebar, the card is picked up. Using the right arrow key, it is moved to the adjacent Done column, and pressing Enter drops the card there. The movement is visually confirmed as the card appears in the Done column, demonstrating seamless keyboard-based reordering and column changes. The demonstration continues to the 2. Sortable Product List section. Here, a vertical list of product items is shown, each styled as a draggable element. The item Apple iPhone 15 is selected and dragged to the last position in the list. Passing items as visual cues highlight the intended drop target. Upon release, the product list updates, displaying Apple iPhone 15 at the end. Next, the item Google Pixel 8 is focused for keyboard interaction. The spacebar picks it up, the up arrow key moves it up one position in the list, and pressing Enter drops it in place. The order in the list reflects this change instantly. The view then scrolls to the 3 Customizable Widget Dashboard section, featuring a dashboard with several draggable widget tiles. The widget Sales Overview is dragged and dropped to the end of the dashboard layout, with the tiles rearranging to accommodate the new position. Then, using keyboard controls, Real-Time Visitors is focused, picked up with the spacebar, moved right with the arrow key, and dropped with Enter. The dashboard widgets visually rearrange to show the new order. Accessibility is further highlighted in the product list. Samsung Galaxy S23 is focused, picked up with the spacebar, and then moved down 2 positions using the down arrow key. Pressing Enter drops it in its new spot, demonstrating that tab navigation and keyboard reordering work seamlessly. Focus states and visual highlights clearly communicate which element is active and being moved. Finally, the demonstration scrolls to the footer, where accessibility notes and best practices are displayed, emphasizing the interface's commitment to inclusivity and usability. Throughout each section, the drag and drop and keyboard interactions are smooth and instantaneous, with real-time visual feedback, accessible focus management, and clear state changes, all implemented using React's useRef hook without any external libraries. You've just unlocked the power to build seamless, high-performance drag-and-drop list reordering in React, completely from scratch, no bulky libraries required. By mastering useRef for direct DOM access, you now have total control. You can fine-tune user experience, boost accessibility, and keep your apps lightweight and maintainable. Imagine how this skill can transform your next Kanban board, dashboard, media manager, or any interface where users expect fluid, intuitive reordering. The best part? You're building solutions that are not just efficient, but truly your own. Ready to keep leveling up with practical, real-world React mastery? Subscribe now. Every video is engineered to fast-track your learning with clear explanations and hands-on patterns you'll use immediately in your projects. Let's keep building smarter together.